air conditioning system for our Valiants and Darts has been completely redesigned. The heating, cooling, and ventilation functions have been integrated. The new system now operates on the reheat principle to provide heating, cooling, and dehumidifying. For the first time, a blend air system is used to provide comfortable discharge air temperature for both cooling and heating. This is entirely different from the temperature control system used on our other air-conditioned models. The refrigeration part of the system is essentially the same as on past model compacts. Minimum evaporator temperature is still controlled by cycling the compressor clutch. However, clutch cycling is now used for the sole purpose of preventing evaporator freeze-up. If the refrigeration system were allowed to operate continuously, the evaporator would get so cold that moisture would freeze on the evaporator fins. Frost could build up and restrict airflow. To prevent this, the refrigeration system is turned off by disengaging the compressor clutch before the evaporator temperature drops below the frost point. On past model compacts, an adjustable thermal switch having a sensing tube inserted between the evaporator fins is used. This switch does two things. Since it is adjustable, it is used to change the temperature operating range of the evaporator. This determines the temperature of the air delivered to the car interior. The thermal switch is calibrated to prevent frosting by controlling minimum evaporator temperature. On the 1973 model compacts, the adjustable thermal switch has been replaced by a non-adjustable antifreeze switch. It opens the clutch circuit before the evaporator gets cold enough to cause frosting. The antifreeze switch opens the clutch circuit at about 33 degrees. It closes and engages the compressor clutch at about 38 degrees. And that takes care of refrigeration system changes. Next, we'll explain airflow and the completely new reheat and blend air setup. This is an art representation of the basic system components. Notice that the blower is located between the heater core and the evaporator. For all operating conditions except maximum cooling, outside air is drawn in through the grill and plenum chamber, which are an integral part of the body structure. Airflow control starts at the inlet air door. Here it is positioned so that only inside or recirculated air enters the system. Here the inlet air door is positioned so that only outside air is entering the system. All air entering the system is pulled through the evaporator by the blower and then blown toward the blend air door and heater core. The blend air door determines what portion of the air will be blown through the heater core and how much will bypass it. It is connected to the temperature control lever. When the blend air door is in the warm position, it directs all air through the heater core. This is the maximum heat position. Here, the blend air door is in the mid position, so that part of the air is directed through the heater core. The remainder of the air bypasses the core without being heated. In the cool position, the blend air door shuts off flow through the heater core. All air is bypassed to the distribution outlets without being heated. This is the mode or air conditioning heat door. Its job is to direct air to either the air conditioning outlets or to the heat and defrost outlets. Here, the mode door is positioned so that cool air is delivered to the air conditioning outlets. In this illustration, the mode door is directing warm air toward the heat defrost door. It has shut off all flow to the air conditioning outlets. When the heat defrost door is in the up position, only a small amount of the air is delivered through the defroster outlets. Most of the air is delivered to the low-level heat outlets. In the down position, the heat defrost door directs most of the air upward to the defroster outlets and the remainder to the heat outlets. So far, we've covered the basic airflow and the various doors used to direct air through the system. Next, let's take a look at the controls and the actual hardware. This is the vacuum-operated water flow valve. It is spring-loaded in the open position. In other words, it allows water to flow through the heater core as long as there is no vacuum applied to it. The control unit assembly is completely new. The fan switch at the left permits selection of high, medium, or low blower speed. A 6-position selector lever is used to obtain the heating or cooling mode desired. These modes are off, max AC, AC, vent, heat, and defrost. In this illustration, you can see that the selector lever is mechanically connected to a combination electrical and vacuum control switch. The electrical portion of the switch turns the compressor clutch and blower motor feed circuits off and on depending on the mode selected. However, the antifreeze switch actually controls clutch cycling and the fan switch determines blower speed. The vacuum part of the switch controls the circuits for the airflow door actuators and the vacuum-operated water valve. The temperature control lever is connected to the blend air door in the heater housing by a flexible cable. Now notice the temperature control lever also operates a vacuum transfer switch. This switch routes vacuum to the water flow valve when the temperature lever is moved all of the way to the left and vent, max AC, AC, or off has been selected. Since the water valve is spring-loaded in the open position, applying vacuum closes it. This shuts off all coolant flow to the heater core. When the temperature control lever is moved approximately 1/4 of its travel to the right, a button on the end of the switch is released. This cuts off vacuum to the water valve. Next, let's get acquainted with the basic air conditioning heater assembly, the vacuum actuators, and the airflow doors. This is the opening that connects to the outside air source. Here, outside air is shut off by the combination outside recirculating air door. Applying vacuum to the rod side of this vacuum actuator opens the door to outside air and shuts off the recirculated air opening at the end of the housing. Applying vacuum to the other side of the actuator moves the door so that the system is open to inside air and closed to outside air. Incidentally, this is the antifreeze switch. The resistor block for the blower circuit is mounted here on the passenger side of the evaporator housing. The entire evaporator housing assembly can be removed from the car for service without disturbing the heater housing and heater core. The evaporator housing is made in two parts. The upper or cover part can be removed, allowing easy access to the evaporator. The lower part of the evaporator housing is referred to as a bathtub design. That's because it is deep enough to collect condensed moisture and has no seams which might leak. The rubber evaporator drain tube is a one-way valve. It is opened by the weight of water collected in the housing. It closes automatically to prevent hot air and engine fumes from entering the system. If the tip of the drain tube is cut or damaged, air will be sucked into the evaporator housing. The resulting airflow will cause condensate to be picked up by the blower and sent into the discharge side of the system. The blower is easily removed from the engine compartment side of the firewall without disturbing the other components. At the left end of the assembly, the entire distribution section can be removed from inside the car. This lets you service the heater core without disturbing the evaporator. Here we see the cable-operated blend air door moving into the warm position. In other words, the door is closing off the bypass so that all air will be directed through the heater core. As the door is opened, more and more air is allowed to bypass the heater core. Next, we'll reassemble the distribution housing and look at the remaining doors and actuators. This double-acting vacuum actuator operates the mode door. Vacuum applied to the rod side closes the air conditioning outlet opening so that all air is directed to the heat and defroster outlets. Vacuum applied to the other side of the actuator shuts off air to the heat and defrost outlets, opens the passage to the air conditioning outlets. This actuator is spring-loaded and has only one vacuum connection. It controls the opening and closing of the heat defrost door. Vacuum pulls the door upward when heat is selected. The spring in the vacuum actuator pushes the door downward when defrost is selected. So far, we've looked at the actual hardware and explained basic airflow. Now let's put it all together and review exactly what happens for each position of the selector lever. When the selector lever is in the off position, the inlet air door is open to inside air, closed to outside air. The evaporator is warm and the blower is turned off because the electrical feed circuits are open. The position of the blend air door depends on the temperature control lever. However, this is not important because there is no airflow. The heater core is cold unless the temperature control lever is moved to the right, opening the water valve. The heat defrost door is up in the heat position. The mode door is open to the air conditioning outlets. When max AC is selected, the inlet air door uncovers the inside air opening and shuts off all outside air. The evaporator is cold because the compressor clutch is engaged and the refrigeration system is operating. To get the maximum amount of cooling, the blend air door would bypass all airflow around the heater core. The heater core would be cold because the water valve would be closed. The mode door is positioned to direct flow to the air conditioning outlets. The heat defrost door is in the heat position, but there is no airflow to the heat or defroster outlets. When AC is selected, the inlet air door is open to outside air. All other system conditions are essentially the same as for max AC. The evaporator is cold. The position of the blend air door depends on how much cooling or how much reheat is desired. The heater core will be hot only if reheat and reduced cooling is preferred. And of course, all air is delivered through the air conditioning outlets. When outside air ventilation, vent, is selected, the system operates on outside air, the same as for air conditioning. However, the evaporator is not cold because the clutch circuit is open and the compressor is not running. The blower does operate at the speed selected. The blend air door position is controlled by the temperature control lever. The heater core will not be warm unless the temperature control lever is moved to the right, in the warmer direction, to open the water flow valve. In other words, you can have heated fresh air ventilation. However, the mode door is positioned so that all air will be delivered from the air conditioning outlets. When heat or defrost is selected, the system operates on outside air. As a matter of fact, heat and defrost are identical except for final air distribution. There is no cooling at the evaporator because the compressor clutch feed circuit is open. The blower operates at any one of the 3 speeds selected. The temperature lever and blend air door control airflow through or around the heater core. For full heat, all air passes through the heater core. The heater core will be hot because the water valve is fully open for both heat and defrost. The mode door directs all airflow to the heat defrost door. It shuts off the AC outlet. When heat is selected, the heat defrost door directs most of the warm air out through the low-level outlets. If defrost is selected, the heat defrost door directs most of the heat to the defrost outlets and much less from the heat outlets. And that wraps up our 1973 compact model air conditioning story. This new system promises to be unusually effective and trouble-free. However, if it does require service, you'll find the how-to information you'll need in your service manuals and this month's reference books.